In chapter 4, I will give two case studies about using ArcGIS Enterprise to analyze geospatial data. The first case is geocoding. Before we start, I want to briefly introduce what is geocode and what is geocoding. Geocode is a geographic coordinates that represent a specific location, which used the most is longitude and latitude. And geocoding is the process of converting a description of a location, for example, address, place name, into geographic coordinates like latitude or longitude. For example, uh, 1737 Cambridge Street, Cambridge, Massachusetts is the address of CGS Naval Building, and with geocoding process, it will be converted to its longitude and longitude 42 N and 70 and 71 double. This is just a process of geocoding. Then why we need geocoding? Why we want to convert addresses to coordinates? For addresses, they are text and can change over time. But for coordinates, they are consistent and remain the same. So coordinates would be better than addresses. And also, geocoded data is easy to integrate into various analysis tools and workflows because we can easily tell the distribution of coordinates, but it's hard to tell where they are located just with addresses. So there are multiple applications of geocoding, like recognizing geographical patterns, analyzing customer data, verifying customer addresses, planning retail locations, mapping optimal routes, tracking the movement of people and goods, and so on. Now let's try to uh, run geocoding process using ArcGIS Enterprise tool on ArcGIS Pro. In this exercise, we will geocode the indicate incidence addresses CSV file. It's also in our GitHub repo. Now let's move to exercise 3. For the third exercise, we will geocode a CSV file using ArcGIS Enterprise Geocoder on ArcGIS Pro. First, let's review the address data in incidence address CSV. Let's open it. For the third exercise, we will geocode a CSV file using ArcGIS Enterprise Geocoder on ArcGIS Pro. First, let's review the address data in incidence addresses CSV. From the file, we can see that it contains 5 fields. The first 4 provide the street, city, state, and the postal code, while the last field contains the full addresses. Then open ArcGIS Pro. Before we start geocode, we need to ensure the current active portal is ArcGIS Enterprise. Then under the Analysis tab, click Tools. In the Geoprocessing panel, type Geocode in the search box and select Geocode addresses. In Input table, let's select Incidence Addresses CSV file. For Input Address Locator, open the browser, expand Portal in the left panel and click My Organizations. And select AGO World Geocoder, Harvard CGA. Now we configure the parameters for the geocoding. The first parameter is input address fields. This maps the address fields used by the geocoder locator. Select a single field if the complete address is stored in one field in the input table, and select multiple fields if the input addresses are divided into multiple fields such as address, city, state, and zip for a general United States address. Select a single field and a country field if the complete address and the country are split into separate fields. And here we can choose both single field and multiple field. But I want to show more about how to set different fields. So here I choose multiple field. And then we can see some fields have been automatically filled. For example, the address or place is corresponding with a street. City is city, state and state, and oh, city, and we can set zip as zip code. And then for output feature class, it is to save the output in shapefile. Then is we need to set output feature class, and we can choose the path and name of the output. To be noted that saving the output in shapefile format is not supported. And here we just output it to the geo database and set its name as incidents. The next parameter is country. It is optional, and uh, it controls the country or countries where the geocoded address will be searched. And this is limited to the specified country or countries. If no country is specified, geocoding is performed using all supported countries of the locator. And from the CSV file, we can see that all these data are located in California. So here we can choose United States. Next one is preferred location type. It is also optional. It gives two options. The first is address location. It is geometry for geocode results representing an address location. For example, a rooftop location will be returned. The first is next parameter is preferred location type. It is optional. It gives two options. The first is address location. It is geometry for geocode results representing an address location will be returned. For example, rooftop location. The second option is routing location. It is geometry for geocode results representing a location near the street, useful for vehicle routing, will be returned. Because we will use this data, the geocoded data, to routing, so we choose routing location here. Next is category. It limits the type of places the locator searches. When no category is used, geocoding is performed using all supported categories. And because we have no idea about what category these data are, so we won't choose anything here. The last parameter is output fields. It is also optional. It includes 4 different options. And the first one is all. It includes all available locator output fields in the geocode results. And the second one is location only. It stores the shape field in the geocode results, maintaining the original fields names from the input table. The third one is minimal. It adds fields describing the location and how well it matches the locator information, like shape, states, score, match type, match address, and address type, while keeping the original field names. The last one is minimal and user fields. It adds the same fields like minimal and user-defined custom output fields. And here I want to show uh, the most fields added to the geocoded results. So I choose all here. Finally, we need to click Estimate Credits. However, since we are using a locator available on ArcGIS Enterprise, no credits will be consumed. So this is just a necessary step in the process. Then click Run. And the resulting point data will be automatically added to the map after geocoding. We can see the address table has been converted to some points on the map. You can open the incidents attribute table to view the geocoding results. Let's pay attention to the coordinates generated. It includes 8 fields. We can explain what they are. Firstly, x, it is the x coordinate, usually longitude or horizontal coordinate for the matched address or location in a coordinate system, as so as coordinate. And these two fields generally represent the street level coordinates used for routing planning. For example, where the location is along the street. Next two are display X and the display Y. They are the address location where the display X represents the display position, often the rooftop or centroid of the building or parts. The next two fields are display X and the display Y. They are coordinates representing the display position, often the rooftop or centroid of the building. These values are best used for displaying the precise location rather than routing. Then the last four are minimum x, minimum y, maximum x, and maximum y coordinates. They describe the extent of the building on the map. For more information on geocoded results, you can reference the official document from Esri, and we also provide the link to the document in our exercise document. And that's all for exercise 3. Case 2 is routing with StreetMap Premium. ArcGIS StreetMap Premium is a product that provides enriched street data for use with ArcGIS software. Its key features include high-quality, multi-scale calligraphic map display and accurate geocoding. Also optimize the routing, driving directions, and the network analysis. and it can cover the whole world, including North America, Europe, Latin America, the Middle East, and Africa, Asia Pacific, and Japan. And why we use StreetMap Premium to route? That's because that StreetMap Premium includes a pre-configured network dataset called routing ND that can be used for routing. And you can perform routing analysis like finding shortest or quickest routes. This is what we will do in exercise 4 later. Or generating driving directions, service area analysis, and the closest facility analysis. The key benefits of using StreetMap Premium for routing. It includes up-to-date street data with traffic information, and it considers factors like one-way streets, turn restrictions, etc. And it also allows for time-based routing with historical traffic data. That's important because we all know that in different time the traffic is different. In 9 a.m. or 5 p.m., that would be very busy. In midnight, it'll be faster. And then it supports various impedance options, including time, distance, or you can customize what you want. And last but not least, it can incorporate live traffic data for real-time routing. Then let's try to calculate shortest drive time. Let's find the shortest drive time from instance to facilities using StreetMap Premium. And that would be the content for exercise 4. And in this exercise, we will use both facilities and incidence data. In exercise 4, we will show a case study about calculating the shortest driving time using StreetMap Premium. And we will use the incidence data, which will just geocoded to calculate the shortest driving time from each point to the facilities. And now we have incidents on the map, so we just need to add the facilities shapefile to the map. And then in the kit log panel, click the portal tab. In My Organization, you will see three network analysis toolbox. These are the analysis tools provided by StreetMap Premium. They are network analysis sync, network analysis, and network analysis utilities. For this exercise, for this case study, select the network analysis tools and the find closest facilities. This tool helps you find one or more facilities that are closest to an incident based on travel time of distance. The outputs include the best roads, driving directions, and a copy of the chosen facilities. For example, it can be used to find the closest hospital to an accident or the closest police station to a crime scene. And we first input the corresponding data into the incidents and the facilities fields. We choose incidents for incidents and facilities for facilities. Then let's set calculation parameters. The first one is measurement units. It defines whether travel time or distance is measured. Choose a time unit to measure driving time or a distance unit for driving distance. And because we can see that all facilities and incidents are located in California, so here minutes is enough. Then the second is next is number of facilities to find. It specifies how many closest facilities to find per incident. For example, you can find up to 100 facilities, such as multiple fire stations for a fire. And here we can choose 2 as test. Next one is cutoff. It is optional. It limits the maximum travel time or distance. For example, if we set a 15-minute cutoff, we'll only return facilities within 15 minutes of an incident. If the closest facilities needs 17 minutes, then it won't be found. And in this case study, we won't set it because we want to get all the closest facilities. Next one is travel mode. It specifies the mode of transportation, such as car, truck, or walking, and you can customize it if needed. And the default value custom allows you to configure a custom travel mode using the custom travel mode parameters. So let's skip the advanced analysis and jump to custom travel mode first. Under the custom travel mode, the first parameter is use hierarchy. When checked, it will prioritize higher order roads like freeways over local roads. It would be very useful when you want to find routes for fire incidents and facilities. Next one is U-turn at junctions. It gives 4 different options and specifies whether U-turns are allowed at intersections. And here we just use the default value, allowed only at intersections and dead ends. Next one is restrictions. And you can impose restrictions like avoiding toll roads or restricted crossroads. It have checked some restrictions and we just leave it as default here. Next one is attribute parameter values. And it sets additional values for restrictions like preferring certain type of roles. And we won't set anything here, just leave it as default. Next one is broad lines simplification tolerance. It simplifies route geometry to speed up processing. And we also leave it as default here. Then next, we will work on the next 3 together. They are impedance, time impedance, and the distance impedance. They define the effort or cost of travel based on time, distance, or other factors. In impedance, there are several options, including time and distance. If the impedance for the travel mode as specified using the impedance parameter is time-based, the value for the time impedance and the impedance parameters must be identical. Otherwise, the service will return an error, so as distance impedance. So here we choose uh, minutes as impedance, then we have to choose minutes in time impedance too, and ignore the distance impedance. Also, if we choose like miles as impedance, then we need to choose miles in distance impedance, uh, but ignore the time impedance. And because we set uh, measurement units as minutes here, it is a time unit, so we need to choose time impedance too. So just changing patterns to minutes. Next parameter is travel direction. It specifies the direction of travel. So that's all for custom travel mode. Then we go back to advanced analysis. The first one we need to set is travel direction. It specifies the direction of travel, and it gives two options: incident to facility and facility to incident. Uh, Maybe at most cases they are the same, but if there are some like one-way road or different speed of two side, that will cause some difference. So it matters, and we will choose incident to facility here. And next one is time of day. It is the time and date the road will be begin or end. And we can set it randomly here because it's just a test, like July 11th, 2024 at 4:33 p.m. And we can set it as start time or end time. Start time means the route will the drive will departure at this time, and end time means it will arrive at this time. Here we set start time. And next is time zone for time of day. It gives two different options. The first is geographically local, which means in this case it will use the Pacific time in California. That's what we need in this case study. And for more details on each parameter, you can check the official document of StreetMap Premium, and we also provide a link in the exercise document. After configuring the parameters, click Run. When finished, we can see there are some output data in the map. They are output facilities, output incidents, output closest facilities, output directions, and output routes. And let's pay more attention on output routes. It displays the best routes between incidents and facilities. And we can open its attribute table, and we can see it give the uh, routes between which facilities and which facility and which incidents, and it give the start time and end time, and give the total distance and total time of this route. That's all for exercise 4.